Nice, huh? Hi guys, Dr. B here. This is topic 3.3, solids, liquids, and gases. I'm kind of mesmerized by this low-key, not even gonna lie. Anyway, moving on. So the objective is to be able to represent the differences between solid, liquid, and gas phases using a particulate level model. Particulate diagrams can be used to show how the different properties between solids, liquids, and gases, how they are. For solids, the particles do not have enough kinetic energy to move freely, only vibrating. There is not much space between the particles because the IMFs hold the particles in place. This results in a rigid, fixed volume and shape. Because of the minimal space between particles, solids cannot be compressed. The location of the particles can either be crystalline or amorphous. Crystalline solids have a repeating 3D structure. Amorphous solids, the particles are disordered. However, in both cases, the molecules do not have enough kinetic energy to move freely. An example is shown here. Notice the highly organized, tight spaces. For liquids, the particles are still close together, but they have enough kinetic energy for them to slide and roll around. This enables liquids to take shape of their container. The close contact of the particles results in liquids being unable to compress. Solids and liquids of the same substance are often approximately the same size between the particles and close together in both states. The temperature range where a substance is liquid is determined by the strength of the IMFs, including hydrogen bonding, dipole-dipole, London dispersion forces. So you see there's a little more disorder. They're still together, but there's some particles that slid on top of one another. For gases, the particles have gained enough energy to overcome the IMFs, holding the particles together. This results in particles being far apart and moving quickly. Because the particles are far apart, gases can easily be compressed. You should remember this terminology from sophomore year when we talk about the states of matter, solids and liquids and gases. So the words I used way back when, 2 years ago when you were sophomores, they're the same words that apply here in AP Chem. They take the shape of their container. Sounds familiar? They have no regular arrangement. The frequency, strength, of the collisions between the particles and the container is dependent on the temperature, pressure, and volume. Particle diagrams can be combined to show phase changes by showing two distinct layers with properties of each state. Of the following, the best explanation for the fact that most liquids cannot be easily compressed is that the molecules in a liquid are in constant motion, are closely together, have varying densities, have a fixed volume, or move slowly or slower as temperature decreases. The answer is going to be B. The particles are closer together as they are not easily compressed. This results in a fixed volume. So the fixed volume comes from the fact that they're pretty close together. Draw a particle diagram to best represent a puddle as it starts to evaporate. So this is asking us to kind of combine both both of a solid, liquid, and gas. Into one diagram. Oh, I can't talk tonight. So if this is where my puddle will be, so remember, water H2O is a little upside down Mickey Mouse. This is my H2O. Wasn't really like that. Okay, it doesn't really give us a fixed number, but this is okay. So now, if that's my puddle, we have to show that it's starting to evaporate. So the molecules are going to start moving up a little bit. The double lines indicate that the particles are moving. That looks really ugly, I'm sorry. Anyway, that's it for now. Let me know if any questions. Okay, thanks, bye.